Hi and hello everyone, this is Ravindra Babu. Welcome back to my channel Silver 90s Biounit. In the last video, we were discussing the mechanism of DNA replication in prokaryotes, but it was incomplete, where we completed only the continuous replication of DNA on the template of 3' to 5' polarity. Still, the discontinuous replication on 5' to 3' polarity is in pending. Before we go into this, let me give you a brief explanation about the continuous replication, to which what we discussed in the last video. The mechanism of DNA replication includes 4 major steps. One is a formation of replication bubble, the second one is formation of replication fork, and third one is formation of a pre-prime complex, and the fourth one is the synthesis of DNA. This fourth and final step of replication, synthesis of DNA, includes 5 substages. One is the addition of primer to this template of replication fork by enzyme primase in 5' to 3' direction. And the second substage is the polymerization of deoxyribonucleotides by DNA polymerase 3 in 5' to 3' direction by using a free 3' hydroxyl group provided by this RNA primer. And the third event is the removal of primer by the 5' to 3' exonuclease activity of DNA polymerase 1. And the fourth event is the synthesis of a short DNA segments in the place of this removed primer, again by the enzyme DNA pol 1 by its 5' to 3' polymerase activity. Okay, and the final stage is the ligation, where the enzyme ligase joins these 2 DNA segments synthesized by DNA pol 1 and DNA pol 3 respectively. Finally, which leads to a synthesis of a continuous and complete strand in 5' to 3' direction, which is said to be as leading strand. The leading strand, it gets synthesized continuously in 5' to 3' direction from outside to inside of replication fork. This is what the continuous replication in brief. Before going to our topic, here a small request from my side. If you want to understand this mechanism of DNA replication clearly, first watch my previous video, that is video number 21 in molecular basis of inheritance. I have provided the link in the description also, you can go through that. And one more request is, if you are new to this concepts of molecular basis of inheritance, watch all my videos made on this molecular basis of inheritance, beginning with video 1. I hope you will enjoy the content I delivered. Let us begin our today's episode, that is discontinuous replication or synthesis of DNA on 5' to 3' template. The synthesis of DNA on this 5' to 3' template is a little bit complicated process when compared to the synthesis of DNA on the template of 3' to 5' direction. The reason is the 5 substages of 4th step of replication occurs only once in the case of the synthesis of DNA on template of 3' to 5' polarity. But in the case of template of 5' to 3' polarity, these 5 substages of 4th step of replication repeats again and again, which finally leads to the synthesis of a new DNA in the form of segments or fragments like this. The synthesis of each of these fragments requires 5 substages of the 4th step of DNA replication. Say suppose for example this is a DNA segment. If it has to synthesize, first it requires a addition of primer. Addition of primer later by synthesis of DNA by DNA pol 3, then removal of primer, then addition of DNA segment in the place of primer by DNA pol 1, and after that ligation of these 2 segments of DNA pol 1 and pol 3 by the action of enzyme ligase, so that the synthesis of a short DNA fragment. Like this, the DNA synthesized in the form of short fragments. Each fragment requires these 5 substages of a fourth step of DNA replication, so that the replication of DNA on this template of 5 prime to 3 prime polarity is discontinuous. Here the question is, why don't this template of 5 prime to 3 prime polarity involve a continuous replication like that of template of 3 prime to 5 prime polarity? Let me make you understand this. According to principle of polymerization, the replication must occur in a 5 prime to 3 prime direction. Therefore, the replication or synthesis of DNA on the template of 3 prime to 5 prime polarity always occurs from outside to inside of the replication fork, because the newly synthesizing DNA must be anti-parallel to the parental DNA strand. If the parental DNA strand is having a 3 prime polarity at this end, definitely the newly synthesizing DNA must have the 5 prime polarity at this end. So, if the replication is taking place from outside to inside of the replication fork, automatically the process of replication would be continuous, because the helicases and the DNA polymerase 3 are moving on the same direction. The DNA polymerase 3 is following the way of helicases. As the helicases moves on further by unwinding the DNA and opening the single strand templates like this, the DNA pol 3 follows these helicases by polymerizing deoxyribonucleotides, thereby synthesis of a new strand of DNA by using this template from outside to inside in 5 prime to 3 prime direction. But there are no chances to happen like this on the template of 5 prime to 3 prime polarity, because the DNA polymerase 3 cannot synthesize a new strand from outside to inside of the replication fork. If it is happen, there would be no anti-parallelity between the daughter strand and the parent strand. Both would have 5 prime polarity at this end. Therefore, the DNA polymerase 3, if it has to maintain the anti-parallel nature of a DNA molecule and to follow the principle of polymerization, it must synthesize or it must show replication from inside to outside the replication fork in 5 prime to 3 prime direction. If the replication occurs from inside to outside of the replication fork, the direction of movement of DNA polymerase 3 and the direction of movement of helicases would become opposite in direction. These movements of DNA polymerase 3 and helicases in opposite direction makes a DNA replication discontinuous. Let us see the discontinuous replication on the template of 5 prime to 3 prime polarity. In order to synthesize a new strand of DNA on this template of 5 prime to 3 prime polarity in 5 prime to 3 prime direction from inside to outside of the replication fork, the enzymes of replication must wait for some time until the exposure of a short segment of DNA template by the action of helicases. Meanwhile, the replication gets initiated on this template of 3 prime to 5 prime polarity as the replication is taking place from outside to inside of the replication fork. But here the replication not yet started here. Here the replication occurs after the exposure of a short segment of DNA template of a certain length. Later, by the action of these helicases, a short segment of DNA template of certain length gets exposed, which results into the initiation of DNA synthesis on this template of 5 prime to 3 prime polarity by going through the 5 substages of fourth step of DNA replication. You know very well, those are first addition of a primer, and it is followed by the synthesis of DNA by DNA polymerase 3, and in the third step this primer gets removed by the action of DNA pol 1, and the DNA pol 1 itself synthesizes a short segment of DNA in the place of primer, and later this DNA polymerized by DNA pol 3 and this short segment of DNA polymerized by DNA pol 1 gets joined with each other by the action of helicases in the fifth step. So in this way, a short segment of DNA will form. It goes on polymerizing the deoxyribonucleotides further like this. But as there is no template for the DNA polymerase cannot polymerize the deoxyribonucleotides further, thereby the process of replication comes to end. Then what happens? How the DNA replication takes place on this template? So in the next step, the helicases moves on further and they opens another short segment of DNA template of certain length, on which again the synthesis of DNA takes place like this. So this is the short segment of DNA template exposed in the first step, and this is the fragment of a new DNA gets synthesized on this short segment of DNA template. In the next step, by the action of helicases, this short segment of DNA template gets exposed here. Here also the DNA synthesis takes place by going through the 5 sub stages like this. So in this way, the process of replication on this template of 5' to 3' polarity occurs in discontinuous manner, which results into the formation of many fragments of DNA. These fragments of DNA are said to be as Okazaki fragments, after the name of its discoverer Okazaki. Later, finally, these Okazaki fragments gets joined with each other by the action of helicases, and it finally results into the formation of a complete daughter DNA strand on this template of 5' to 3' polarity. This new DNA strand synthesized on this template of 5' to 3' polarity is called lagging strand. Lagging strand, as its synthesis is lagging behind the synthesis of a leading strand, and the replication of this strand is in discontinuous manner, and the replication occurs from inside to outside of the replication fork. Let me show you these 5 sub stages of the 4th step of replication one by one on this template of 5' to 3' polarity. This is the template of a 5' to 3' polarity of replication fork, and here I am considering this as the segments of DNA templates exposed by the action of helicases at regular intervals. This is the first exposed segment of the DNA template, and this is the last exposed segment of DNA template by the action of these helicases. Here let me show you the 5 substeps of the 4th step of DNA replication on each of these 5 segments. In the first segment, in the latest formed segment, you can find the formation of the addition of primer by the enzyme primase, and in the second step, what happens? The addition of primer and synthesis of DNA by DNA pole 3 in 5' to 3' direction you can find, and on the third step you will find the removal of primer, so that only you can find the DNA segment synthesized by DNA pole 3. What is the 4th step? The 4th step is the synthesis of DNA in the place of primer by DNA pole 3, and this is the DNA segment already synthesized by DNA pole 3. Okay, and in the last step what happens? The DNA ligase comes into action, which combines the short segment synthesized by DNA pole 1 with the large segment synthesized by DNA pole 3, thereby it forms a complete DNA fragment. To that what we call Okazaki fragment. Okazaki fragment. Here in the first step you will find the addition of primer, and here the DNA pole 3 comes into action, which synthesizes a new strand of DNA. Here the 5' to 3' exonuclease activity of DNA pole 1 removed the primer, and here in 4th step the 5' to 3' polymerase activity of DNA pole 1 synthesize a short segment of DNA here, and in the final step the DNA ligase which joins the 2 segments to form a Okazaki fragment. And finally, all these Okazaki fragments gets joined again by DNA ligase to form a complete strand of DNA on this template of 5' to 3' polarity. Meanwhile, the enzymes topoisomerases and the 3' to 5' exonuclease activity of DNA polymerases performs their function during the process of replication. And here all the enzymes whichever involved in this process of replication along with the pre-prime complex considered to be as a replisome. So replisome is nothing but the combination of all enzymes and proteins of replication including primosome is said to be as a replisome. And finally, in this part of video, let me give you the differences between the continuous replication and discontinuous replication. So this is a continuous replication and it is a discontinuous replication. The discontinuous replication requires single primer or single primase, and it requires single primer and a formation of a single primosome during the synthesis of a DNA strand. And here the continuous replication occurs on 3' to 5' template of a replication fork, and here the newly synthesizing strand on this template is called a leading strand. When we come to discontinuous replication, here it requires many primase, and many primase requires many primers, so that the formation of many primosomes. Discontinuous replication occurs on the template of 5' to 3' polarity, and here the newly synthesizing DNA strand is said to be as lagging strand, as its synthesis is lagging behind the synthesis of leading strand on the template of 3' to 5' polarity. This is all for this today's topic. In the next video, we are going to talk about the replication in eukaryotes and differences between prokaryotic replication and eukaryotic replication. Thanks for watching. Hit the like button, share the video, subscribe the channel. Keep watching. Vidyaya Amrutam Ashnute.